Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at lesson 5.3.4, and in this lesson we are going to start using variables and variable equations to make our jobs easier. Now, that all presumes that you are comfortable and confident with solving equations, and we haven't spent a lot of time going through the processes for solving equations. We're going to actually get into that in a future chapter, but there's no time like the present. I know you did a little bit in 6th grade, and you know the basics. So let's just use what we know of the basics and see if we can't be much more efficient with solving these equations. Or solving these word problems. Okay, so it says today you will continue to use the 5D process as you solve word problems. In this lesson, you will use a variable to represent the unknown value in the problem. Think of these questions as you work in the problems. What is the problem asking? What is the relationship between the quantities involved? And how can I choose which part of the problem to represent with a variable? Okay, so we are going to get started with this problem that has to do with chocolate blasters. Okay, so remember, we read through the problem. Maybe I shouldn't have all this highlighted to begin with. Let's highlight it as we go. Okay, so it says Mai has 1 mini box of chocolate blasters candy, and Warren gave her 3 more pieces. Okay, Samara has 2 mini boxes of chocolate blasters and gave 6 pieces to Will. So at first, it looks like we've got 4 different variables here, but to be honest with you, I think we only have 2. I think we've got Mai, who has 1 mini box of Choco Blasters candy, and then Warren gives her 3 more. So she has a box, and now 3 more have been added to that. So she must have 1 box plus 3 pieces. And I don't care about how many Warren has. Because it says now Maya. So how many chocolate blasters are in a mini box? So yeah, we're just talking about Maya and Samara. Okay, so let's read about Samara. It says Samara has 2 mini boxes of chocolate blasters, and she gives 6 away. So hers are 6 boxes minus the 6. And then this last piece is kind of important because it says that Maya and Samara now have the same number. Okay. So let's think about what we are going to describe. What are we talking about here? I think we've got 2 people basically, right? We've got Mai and we've got Samara with their number of chocolate blasters and the fact that they have the same amount. And the question that's being asked is how many chocolate blasters are in a mini box in each one of these boxes. So when we declare our answer is just going to be straightforward. This is the number of chocolate blaster candies that can be found in 1 box. Okay, so let's look back at what we've highlighted and define what we've got here. It says Mai has 1 mini box plus 3 more that Warren gave her. So that's if we don't know how many chocolate blasters are in a mini box, that would be the variable that we would say X. So she has 1 full box plus 3 extras, and Samara has 2 of them minus the 6 that she gave away to Will. So how are we going to go about solving this problem? This has to be equal to that, correct? So let's take this information here, and we're going to start with Mai, and hers is X plus 3, and then we're going to go to Samara, which will be 2X minus 6, and what we have to do is make those equal to each other. If they are equal to each other, then we're going to know that we've got the answer. Okay? So let's start with just guessing a random number inside the box. So if we guess 20, Mai is going to have, maybe I should bring this down here. She's X plus 3, and Samara is 2X minus 6. So if Mai has, if the box has 20, then Mai would have 23, and Samara would have 2 times 20, which is 40 minus 6. So Mai would have 23, Samara would have 34. That is not the same. They are not equal to each other, so that cannot be the number. So now I'm going to jump to 15 and see how that works. So that means she's going to have 15 plus 3, and she'll have 30 minus 6, which is 18 and 24, which is still a no-go. So let's drop it down to 10. See what we get there. That gives us 13 and 14, that is very close. So I don't want to jump down by 5 anymore. I'm going to just go down by 1 and see what happens if we say that's 9. And then that ends up being the magic combination. 9 plus 3 is 12, and 18 minus 6 is 12. So we can declare that there are 9 Choco Blasters in each box, or each box has 9 Choco Blasters. Okay, so you see how we work through that process? Now, let me show you how I would do this algebraically. I'm going to put these guys back up here, and we're going to make them equal to each other. If I want to do this, it'll take 2 steps. My first step is for me to take away 1x from each side, because we don't like having in algebra x's on both sides of the equation. So I'm going to remove what we call balanced sets. Whatever you take away from one side of the equation, take away the same amount from the other side of the equation. It's kind of like a scalar balance. So if you have 2 things that weigh exactly the same on a balance, then when you take away the same amount from each side, it's going to remain balanced. When you add the same amount to each side, it's going to remain balanced. So I'm taking away an x from each side, and now I don't have x plus 3 anymore. Now I just have the 3, and here I used to have 2 x's, but now I only have 1 x because I took one of them away. So now I'm going to do the same thing, but this time with the number part, with the constant. I want this x to be all by itself. So I'm going to think of whatever number I can add to negative 6 to make it equal to 0, and that ends up being positive 6. So I'll add 6 to each side, and that's how I get 9 is my answer. So you see the number of steps it took me. Once I knew what my equation was, it took me 1, 2 steps to get to my answer. And now I will check it. Is 9 plus 3, which is 12, equal to 2 times 9 minus 6, which is also 12? Yes, it is. We will still do the whole decide thing when we do it algebraically, but now we know. We're just going to go straight to that number to check it, and then we can declare our answer. Takes a lot less time, doesn't it? All right, so Alan's team was working on a problem but did not have time to finish it. They also did not follow the teacher's directions for showing work in the define section. Discuss with your team what information you can get from Alan's table below. Well, we're not going to discuss it as a team because you're not sitting in your group in the classroom, but let's just look at this. For this particular situation, looks like we've got a length and a width, which makes me think we've got a rectangular shape here. It says double each side and add together. This is the formula for finding the perimeter, right? When you take any kind of a rectangle, where are you, rectangle? You've got 4 sides. This is your length, and this is your width. So you got 2 lengths plus 2 widths. Ends up giving you the total perimeter, or the distance around the shape. So this is a perimeter problem. And our first trial says 3 and 9. So 2 times 3 plus 2 times 9 is 24, so that's too small. When we up this to 4, oh, we've got a problem here. And I think this leads right into it. Is there enough information in Alan's table to finish the problem? I don't know what number to put there, because I could add 6 to this number. So it could be that the width is 6 more than the length. The width is 6 more than the length. It looks like I got those backwards, don't I? Whatever, doesn't matter. Or could it also be that this is times 3? So we would times 3 on that one. We don't have enough information, and I think that's what was being stated up here. Alan's team was working on a problem but did not have time to finish it. They also did not follow the teacher's directions. I have no definition here. While I know the length and the width, I don't know the relationships between them. So our response to this is there enough information? No, we don't know how. No, hold on. We don't know, we don't know how they got the width. And what would you need to know in order to complete trial number 2? Explain your thinking. So we need to know how you get the width from the length, right? What is it that you're doing to the length to get the width? We need to know that relationship. All right, so Alan's teammate Scott was also working on problem 129, but he did his table differently. As Scott explained his table to Alan, he used the pattern in the first 2 trials to represent the quantities in the 3rd row with the variable x. So he is now defining the situation with variables, okay? So look at the table below. How is it different from Alan's table? Well, Scott showed his work for how to get the width, right? It looks like you take the length and you double it, and then you add 3, right? If it was 3, 2 times 3 plus 3 gives you 9, right? So 3 plus 3 and 9 plus 9 gives us 24. Alan just wrote the 9. So Scott did a good job of showing the work, so the next person who comes up will know exactly what to do in each of the trials. So what does the x represent in this particular situation here? Well, isn't that the length? That's the variable for the unknown for the length. And in words, describe the relationship between the length and the width. So what would you say there? What are you doing to x to get the total width? Looks like we're doubling it and then adding 3, or you could just say that the width is 3 more than twice the length. And you can word that in a number of different ways. Okay? So where did the expression x plus x plus 2x plus 3 plus 2x plus 3 right here highlighted, where did that come from? Coming back over to here, remember how we find the formula, or how we find the perimeter? The formula for the perimeter is to take 2 times the length plus 2 times the width. So that's what's going on here. This is 2 times the length, and that's 2 times the width. So if we want to continue with this trial where we just plug in numbers, we can. One thing I know for sure is that the length has got to be between 3 and 6, right? Because 3 was too small and 6 was too large. Now, I hope it's either a 4 or a 5, because that would be a nightmare for us to do a guess and check table and have the length be like 3.4 or 4.7 or 5.18. Those would be ridiculously hard to do in a table guess and checking. And that's why we love solving algebraically so much, because it doesn't matter how complicated the number is. If you solve the steps in the equation, you will get the answer, right? Okay, so I'm going to draw the picture where we know the length is 3 more than twice the width. And so when you combine like terms, you end up with the expression 6x plus 6 for the perimeter. And since we know that the perimeter here is 36, then we'll say that 6x plus 36 is equal to 36. So now we'll solve for x by using legal moves. And the first legal move is to remove balanced sets. Whatever you take away from one side, take away the same amount from the other. And we're purposely going to choose to take away this 6 so that we can just get our 6 x's all by themselves. We used to have 36 on the right, but we took away 6, so now we're going to have 30. And now the last step, what do you multiply times 6 to give you 30 for an answer? Well, that would be 5. So I'm pretty sure we've got our length. Our length has to be 5, and that makes sense. We said it was supposed to be between 3 and 6. But I'm going to double check it, and this is where the decide comes into play. Instead of doing the decide in the table and having it magically work out here, we'll just plug it in here. If this is 5, this has to be 5, and this has to be 13, and this would have to be 13 because that ends up being 2 times 5 is 10, 10 plus 3 is 13. So now let's add all of those together. We'll take 10 and 26. Those two add up to 36. That is it. That was our decide section. And now we can declare our answer. The length is 5 units and the width is 13 units. So can we all agree setting up the equation and then solving for x is the easiest, most efficient way to get to an answer? Much, much better than taking all this time setting up the table. But I'm going to say this. If you are still struggling with these concepts of solving equations, you don't have to. Use the table. I don't mind. I love it when people graduate to solving using equations, but if you get every answer correct and get 100% on the chapter test by setting up tables and working through the process, wonderful. That's what you should be doing. Okay, so you make the decision which one is better, but I would like for you to practice this because I'm promising you it does get easier and it is much, much faster. All right, here's an interesting idea. The concept of consecutive integers, that's going to pop up in our M&Ms. Consecutive integers are integers that come run right after the other when you are thinking about the number lines. For instance, the numbers 1, 2, and 3 are consecutive integers. They're each one apart. 14, 15, 16 are consecutive integers, and notice how they get more as you go up. So we're never going like 3, 2, 1 or 16, 15, 4. No, we're going in order on the number lines 1, 2, 3, 14, 15, 16, or the negative numbers go from least to greatest, -5, -4, -3. Okay. So if we had a problem here that said sum of 3 consecutive integers was 57, what are those 3 integers? Well, we could just start with a number and say, well, if one of them was 15, then the next one would be 15 plus 1 would be 16, right? And the one after that would be 15 plus 2, which would be 17. And so if we add all those together, 48 is too small. Maybe we have to start with a bigger number. So now we start with 20. And if the next number would be 21, because that's 20 plus 1, and the one after that would be 20 plus 2, because that would be 22, right? So each of these numbers, if we write it as an expression, we start with the original, the first one, and then the second one is always 1 more than the first one, and the third one is always 2 more than the first one. See that pattern there? What we're going to eventually have to do is this. We are going to add these together, right? So this is the first number, this is the second number, and this is the third number. And when you combine like terms, that ends up giving us 3x plus 3 is equal to 57. So what I would like for you to do is I would like for you to find out what number x is. And once you know what x is, we can now declare for the other 2 numbers. We'll have everything we need for all 3 numbers. Okay, go ahead and pause and see if you can work that out and solve for x. All right, I'll walk you through the steps. First of all, we want these 3 x's to be by themselves. So I'm going to take away this 3 that's being added on there. So remember, if 3 x's plus 3 was equal to 57, we're trying to figure out what the 3 x's were before we added the 3 on. So if we take away that 3, we see that the 3 x's must have had a value of 54. And now, what do you multiply times 3 to give you 54? Well, let's do that with the calculator. 54 divided by 3 gives you 18. So that means that x must have been equal to 18. So let's double check to make sure that this works. Let's take 18 plus 19 plus 20. That ends up being 37 plus 20, which is equal to 57. Yes, that's what it's supposed to be. So 18 was the right number. So we can declare our numbers are 18, 19, and 20. All right, Maiko saw someone's expressions in the 5D process table below and wanted to reverse the process. The problem involved a bag of green, red, and blue marbles. Okay, so do you notice how we've got our definitions here? Looks as if there are 2 fewer red marbles than green marbles, and there are 5 more than twice the number of green marbles. I should say the number of blue marbles is 5 more than twice the number of green marbles. And when you add all of those numbers of marbles together, what do we get? We get 71. So after analyzing that, let's answer these questions. It says, one of the variable expressions describes how the number of red marbles compares with the number of green marbles. How can you describe this relationship in words? Okay, this is what I would like for you to do. If you want to go back and listen to what I just said, rewind it a little bit, feel free to do that, and then pause. And I want you to read each one of these questions, and I want you to answer A through D. Okay? Go ahead and pause and take care of that, and then I will reveal the answers. All right, so how can you describe the relationship between red marbles and green marbles? I said number of red marbles is 2 fewer than the number of green marbles, right? And based on the variable expressions, use words to describe how the blue marbles compare to the green marbles. So we said that that must be 5 more than 2 times the number of, I guess I couldn't fit it, of green marbles. So how many total marbles are there? Well, we highlighted that, right? There were 71 total marbles in the bag. And so if there are 15 green marbles in the bag, how many red marbles would be in the bag? Well, that would be this first row, right? So if there were 15 here, there must be 13 there. And then this would be 30 plus 5 to give us a total of 35, right? So 15 minus 2 is 13 red marbles. 30 plus 5 equals 35 blue marbles. So now we are going to finish the process, but we're going to do it algebraically, okay? So we know the number, let me go ahead and highlight or make the parentheses here. This would be the number of green marbles. This is the number of red marbles, and this is the number of blue marbles. When you add all those marbles together, we're supposed to get 71. So our first step is to combine like terms to get 4x plus 3 equals 71. Now, what's the next first step? Or what's the next step? The first step of solving this after we've combined like terms. We want to get rid of that 3, right? So we want to know what 4x's were equal to before we added the 3 and got 71. So if we take away that 3 from each side, we would get, let me go ahead and show that. I like to show the removable balanced sets. They would cancel out, leaving you with only the 4x's, and 71 minus 3 is 68. Now, what do you multiply times 4 to give you 68 for an answer? Well, let the calculator do that for you. 68 divided by 4 is 17, which means in this particular situation, there must be 17 green marbles in the bag. So if there are 17 green marbles in the bag, there would be 15 red marbles, and there would be 34 plus 5 blue marbles. So for the decide portion, we need to add all those together. So our 17 plus 15 plus 39 equal to 71. Well, 17 and 15 makes 32, and 32 plus 39 is 71. Yes. So we got our answer. We can now take these numbers right here, the 17 for the green, the 15 for the red, and the 39 for the blue, and we will properly declare our answer by labeling these numbers appropriately. If you just write 17, 15, and 39, but you don't label which one is which, you are going to get marked down. Okay, I want to make that clear. You would get marked down for that. So make sure that your answer is written properly and completely. And that ends our lesson for today. So let's move on to the next activity. Take care.
Hey, feeling good, like I should.